we're just talking about the question, what is a logarithm? So we want to be able to answer that question, and maybe we'll see that they're not so bad. So we'll just get started. So a typical log would look something like this. All right, and so I want to go, first of all, how it's read, and then secondly, what question is it asking? So we read logs like this: log base 2 of 8. That's how it's read. So the little number is the base, and the number beside the log is technically inside of the log. So it's log base 2 of 8. Okay? But it asks the question, it's asking 2 to what power equals 8? That's the question that it's asking. So if you understand that, then it makes logs a lot easier. So for instance, if I just put a question mark here, as that's what I'm trying to figure out, what's this answer? So this is asking 2, so this here is looking for an exponent. This is asking the question 2 to what power is 8? Well, what's the answer to that question? 3. So you could also write this question here like this. These are synonymous. 2 to what power is 8? This is asking 2 to what power is 8? The same. So it's asking for the exponent. It's like we're working backwards. Let's put our phone up, please. It's like we're working backwards. Typically, when you do exponents, you do what? How would you typically do an exponent? You would typically do this. 2 cubed equals what? That's typically how you do an exponent. 2 to the third is what? Well, that answers 8. Well, we're working backwards. We're given the answer, now we got to find the exponent. So the answer to this would be log base 2 of 8 equals 3. And so you should be able to say 2 cubed is 8. And this is the log form of a logarithm. And you can always write a logarithm in exponent form. This is the exponent form of a logarithm. Okay. So really, it's just I'll put a couple more, but that's really it. Okay, if you can do that, then you can do logs. Okay, so see if you can answer these 3. So log base 5 of 25 equals what? Log base 16 of 4 equals what? And log base 3 of 1 equals what? Might be helpful to write them in exponent form so you can, if you can't picture what it is. So the first log is asking what question? That's exactly right. 5 to what power is 25? Hopefully you can do that one, right? So what's the answer to the first one?
5.
Not 5. You're doing multiplication. 2. You got to do exponents. That will be a common mistake is students will multiply and not do exponent. So just better guard against it. Yeah, so 5 squared is 25. So let's write this out. This is 5 squared 25, yes. A lot of times when you write that down, then had you put a 5 up there, you would have known it would be wrong, right? So it's helpful, I think, to write it out. Okay, so there's the first answer. All right. Second one may not be as easy, but it is once you think about it. So what's the answer to the second one? Anybody? 1/2 is exactly right. So you write it like this: 16 to what power is 4? Okay. Well, you know that the square root of 16 is 4. And square root is the same as raising something to the 1/2. So you need to be comfortable in knowing that square roots into the 1/2 power are the same. Cube roots into the 1/3 power are the same. So when the number is smaller, you know it has to be a fraction to the 1/2 power, to the 1/3 power. Okay? Well, except for the last one, right? But that's not a fraction. So this answer is 1/2. Because it's asking 16 to what power is 4? Square root of 16 is 4. 1/2. All right, last one. 0. That's exactly right. Because how can you do 3 to a power and get 1? That's where you know so what properties would be helpful here? Exponents. 3 to the 0 is 1. It's 0. So let me ask you this. Had I changed the base to a different number, let's just say I did log base 7 of 1, would that change the outcome? No, because it's going to say 7 to what power is 1. You're still going to have to say to the 0. And that will be our first main property of logs. So notice, as we understand what is a logarithm, now we're going to put some basic properties. And so the first basic property we're going to put is that we know that log base A of 1, so I'll put base A as any base. Let's just say that our base has to be, just as I write these out, our base is greater than 0. Yeah, it's not all the way in the picture there, so let me just move it over a little bit. We'll say our A is greater than 0, log base A of 1 is 0. That's the first property. So I'll use base A to represent any base. Okay, so there we go. All right. Now let's look at some other shortcuts. See if we can find a couple of other ones. Answer each one of those. And then see if you can see the theme or the pattern to it, what I'm trying to get at. After you do a couple, it should be pretty easy. Then you'll try to, maybe you can see what the property is. So what's the answer to the first one? 1. So it's asking 2 to what power is 2? 1. So what do you know about the base and the inside? They're the same. 3 to what power is 3?
1.
So what's our shortcut? What's our property now? Let's make it general. Let's generalize it. Log base A of A equals. There you go. All right, very good. Okay. Now let's see if this one makes it. I call this one Mr. Obvious. You'll see why I call it that.
So see if you can figure out each one of those. Now, again, let's just say there's a lot of numbers going on, right? Let's make sure we're clear on one thing. This 5 is the what? Base. This here is on the inside. All of that's on the inside. So let's make sure we understand the question. This is asking 5 to what power is the inside? And the inside is 5 cubed. So when you rewrite it, and again, I call this form what form? What is this form? No. Exponent form. Mr. Obvious is the rule. Because you're going to see in a second, it's obvious what the answer is. You just don't, that's why it's Mr. Obvious. Okay? This is exponent form. So I'm writing it in exponent form so that it becomes clear what the answer should be. So if there's a lot going on in here and it just scrambles around in your brain, just say, okay, put your question mark, 2 to what power is 2 to the 4th? Oh my goodness. Okay, Mr. Obvious. See if you can answer those. And then let's see if we can figure out what the shortcut or what the property is. Go back to always what the log is asking. It's asking, right? This is read log base 2 of 2 to the 4th, but it's asking 2 to what power is the inside? The inside is 2 to the 4th. Got it now? Easy. So what's the answer to the first one? 3. Second one. 3rd one. Last one. Now you see why it's Mr. Obvious. So students want to say these cancel. No, that's not. That's that's what it looks like, right? It looks like, well, all that cancels and you get 3. No, it's not. I know you want that to happen, but that's not. It's just answering the question. 7 to what power is 7 to the 3? 3. It's just Mr. Obvious. Okay, so there's no canceling. It's just that's the answer. Now, it reduces. Now, so here might be my advice, okay? So if you have this, you could take 81 and write it as 9 squared and use Mr. Obvious. Either way, you're going to get the answer. Okay, what's the answer? 2, but it's easier here. Okay? So what would that property look like? We'll say log base A of A to the X. And so if we have that, what's the answer to the question? X. Mr. Obvious. Okay. All right. Now, real quick, let's just make sure we're comfortable going from a log to an exponent and an exponent back to a log. So we'll go back to our first one. We had this, and we could write it like this. Log base 2 of 8 is 3, 2 cubed is 8. Let's say you had log base 2 of 16 is 4. So let's say we went ahead and had it written out. How could you write that as an exponent? No. 2 to the 4th is 16. That's the order it goes in. Okay? Because that is the exponent. Okay? All right. Now, write that as a log. After that, write that as a log. All right. So how do you write the the first one as a log, what would that be? Log base 3 of 81 equals 4. Okay, so it's like the answer's already given. I'm just trying to get you comfortable with the forms. Okay? So again, this is log form of a log. This is exponent form. All right, what about this one?
Log base a of x equals what?
There you go. And that I kind of include in my properties of logs, is the way you can rearrange a log. So I would add that. So this is just showing you the log form and the exponent form. So log base a of x is y. It's synonymous with saying a to the y equals x. Okay. And those are your 4 first properties of logs. Okay. So the first part of the assignment is going to ask you to work some of these problems and get you comfortable with it. Now, a couple of things that we need to add are the two logs that don't write the base but are understood. Okay, so let's just make sure that we add that and we know what those 2 logs are. So what are the 2 logs that don't write the base but you need to know the base? Crickets. All right, so one of them is the common log. And common log is log base 10. So if you have log, say we had log base 10 of x, it would just be written log of x. So if you just see log of x, it's understood that the base is 10. Okay, that's called a common log. So base is not written, but it's understood. So if I ask this question, log of 1000 equals, you know that if we put log and we don't put a base, that the base is 10. And then you can go and answer the question. What's the answer to the question? 3. Just count the zeros, right? So if it helps you to put a 10, you can put a 10. Then say, well, yeah, I don't like how this looks here. So yeah, you can just say it's the same as saying this, if it helps you to put it. And it's asking the question 10 to what power is 1000? Anytime you're doing powers of 10s, just count the zeros, right? 3 zeros is 10 cubed, 2 zeros is 10 squared, and so on. How else can you do this? If you wanted to use something that cost about $90, type it in on your calculator. You got the LOG button. It's the one that says LOG. Hit log of 1000 to give you the answer. You got a log button? Is it there? Okay. All right. Who knows the other log that has the base is understood? Okay, good. That's a good, great answer. Natural log. Base is E. So if you see ln of x, right, it's written ln, that stands for natural log, and that's the same as saying log base E. Okay? You remember why is it called natural log? Because E is called remember I called it a DJ natural base? Yeah. Would be a cool DJ name. It's the natural base. So E is the natural base, so that's why we put ln. ln for E. So really, if I just go in and put 9, I can't really answer this without a calculator. I have no idea. Well, I mean, I have an idea, but I'm not going to get there. Because it's asking, what question is this asking? Very good. E to what power is? 9. Do you remember what E is from our talk the other day? 2 point something. Yeah, it's 2 point. Get the 7 for me. At least get 7. Yeah, so it's 2. So it's asking 2.7 blah 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 to what power is 9? I don't know. Luckily, if you get something like this, we use our Walmart special or whatever, wherever you got it, right? Walmart, Target. Walmart's good. They always take it back if it breaks. They're all the same. So what does the TI-84 say? Yes.
And then we close the first.
Sure, and then you hit enter.
2.197.
There you go. That's it. I can't do that one in my head, so be able to compute them, okay? All right, very good. So let's make sure we're clear. A common log is base 10, but you won't see the base. A natural log is base E, but they'll put ln. Okay? Now, what's something you could do by hand? You could do this. Ooh, finally I got it. Fresh mark. 7, thank you, it's Mr. Obvious. What I remind students is this has a base, it's not written. What's the base if it's ln? What question is this asking? E to what power is? Come on. Okay. So if you have ln of E, you know it's Mr. Obvious. Okay. All right. Good. So what is a logarithm? Do you feel better about them now? Okay. How would you describe it? How would you, so go back to the very first one, and I erased that. All right. How would you describe a logarithm? If that was the first question I gave you, what is it then?
Finding the missing exponent.
What's that?
Finding the missing exponent.
That's exactly what it is. Finding the exponent, working backwards on an exponent one. You're figuring out the exponent, that's it. So good answer. Finding the exponent, plus 1,000 minus 1,000 points. There for a second she was done, and then we took it all away. Now she has to keep working. Because if you're plus 1,000, you can pretty much stop for the rest of the semester, right? Or the rest of the year. But then that minus 1,000, we took it away. We got some basic properties of logarithms. Okay. I still haven't looked. Was it you or your brother showed me the Drake equation?
It was me.
I gotta look at it. I haven't. I'm still interested. I'm gonna go on YouTube and. So. Does this look familiar?
Yes.
It does?
Yes.
Good. What is it? What was it? Dominator. Like she said that so confidently, I'm excited to hear her answer. That thing I circled, right? Is that what we're
Oh, I thought you were talking about the lesson.
Oh, yeah, that's, yeah. When's the holidays come?
I mean,
This right here, does this, in terms of what we've done this school year, does this look familiar? Not at all. Almost.
Kind of.
It's close, right? But that's where I wanted you to go. Now, I think with exponents, I think when I defined them, we did a B, right?
Yeah.
All right, so take that out. Remember, so here's this. So what does an exponential equation look like? Y equals, let's just use A as the base. It would be what? Y equals what? There you go. But this is x equals a to the y. This is your exponential function. And so let me do some erasing here because I want to kind of refresh my memory. All right. And let's just say, just for, so we can kind of paint a picture. A is greater than 1. Do you remember, so if we look at this, y equals a to the x. A is greater than 1. Before today, what would you tell me that picture looks like? The whole lesson that I just did on exponential functions, that's right. It would be called what? What do you call that? Exponential growth. Crosses the y-axis where? Crosses the y-axis where? At 1. So this, as the point 0, 1, it grows exponentially And it has what down here? Horizontal asymptote. Okay. Now, if this is a log, what do you notice has happened with x, y, and x? What have they done? What do you call a function when you switch places with x and y? That's exactly right. This is the inverse function. So for the exponential function, this is your exponential function that we've already studied. Exponential function, a logarithmic function is the inverse. So that means if this graph has the point 0, 1, what point does this graph have to have? 1, 0, that's right. Okay. Let's have that point. And let's just say this was, let's give this a base. Let's say this was y equals 2 to the x. I think that was one where we did all the x's and y's. You remember like -2, -1, 0, 1, 2. You remember what the answers were? 1/4, 1/2, 1, 2, 4. Okay. So that means, so I make this x equals 2 to the y. All right. What should the points here be? I'm just going to put x and y. What should happen if you don't look at trying to plug in? What should happen if you go from something to its inverse? Switch them. So it should be 1/4, 1/2, 1, 2, and 4, right? And then you should get these answers, -2, -1, 0, 1, 2. Now, I can write this y equals, because this is a logarithm. So if it's x equals 2 to the y, or 2 to the y equals to x, what's the log form? Log base 2 of x equals, there you go. So that's the equation. So let's plot these points and see what happens. So 1/4 -2 down there. 1/2 -1. 1, 0 I got. 2, 1. And 4, 2. Now look at this picture and look at this picture. All right? Do they look like they're, remember what symmetry do you have to have if you're inverse functions? Not the origin. Y equals x, remember? Yeah, so that diagonal. So what do you think here is going to happen to this horizontal asymptote? It's going to be a vertical asymptote. That's right, it's right here. There you go. Okay? So what I want you to see is what we've done is we've given you the basic log graph. See, we knew that all basic exponent graphs look like this. All your basic log graphs are going to look like this. They're all going to cross at 1, 0. And they're going to go in this direction. And you're going to have a vertical asymptote here at x's. Okay? I'm going to erase so we can just generalize this. We erase our exponent. So again, what I did was I said, all right, okay, if y equals a to the x, a is greater than 1, we know it looks like this, exponential growth. Well, now if we want to draw y equals log base a of x, instead of using a is greater than 1, it's going to be logarithmic growth. So 0, 1 becomes 1, 0. It has a vertical asymptote. So this has a vertical asymptote at x equals 0. Okay? All right, a couple of questions. What would you say, looking at this picture, is the domain of the logarithm? And what would you say is the range? So again, all I've done is this generalizes all exponential base greater than 1. And this just generalizes, since they're inverses, this generalizes all your logarithms. But this is log base 2, log base 3. You can even type in, go to y1 and just type in ln of x or log of x. You're going to get this picture. Okay, you can just double check. They're all going to look like this. And just their steepness may change, but yeah.
Oh, I know the domain.
All right, what's the domain?
The domain is not including 0 to infinity.
All right,
and
so
range
let's
is
stop for a
all over.
second. Does that make sense? Don't include 0? That's right. And then what's the range?
Negative infinity to infinity.
Yeah, so it goes down forever and it is climbing. It's just going slowly, not as fast as that, but it is climbing. So the range is all real. Okay? So let's talk about that. So what you're telling me is, if I have a logarithm, I cannot plug in 0.
I mean, you could try.
Yeah, but you shouldn't be able to, so let's understand why. So let's just say this is your log base 2, right? And what you're saying is that 0 should not be in the domains. So let's think about that. Log base 2 of 0. Let's just say you try to plug in a 0. So what question is this asking? 2 to what power equals 0? And guess what? It's impossible. You can't take 2, sorry, that's supposed to be a 2. You can't take 2, raise it to a power and get 0. Also, what else can you not plug in according to this picture? Negatives. All right, so let's look at it. Let's say we try to plug in a -1, log base 2 of -1. So this is asking 2 to what power is -1? That can't happen either. You can't do 2 to a power and get a negative. So that's why it stops here like this. Now, it can shift. So, what would happen? What do you think would happen? I'll just stick with our log base 2. If I did x minus 3 on the inside. Shift to the right 3. So just the basic transformations, don't forget them. Remember, if it's inside, it's horizontal. If it's outside, it's vertical. Okay? If it's in here, or I'm sorry, a negative here, it flips it. All that stuff stays the same. So yeah, so all I would do real quick, I know my basic graph. Let's see, it's going to move right 3. So where would this vertical asymptote be? The whole picture has to move. 3. 1, 2, 3. Where would this intercept move to? 4. And I would redraw. So now does that change your range at all? Range. Does it change your domain? So a real easy way, look, whatever makes the inside 0, that's going to be your vertical asymptote, similar to how we did rational functions. Okay? That's going to be your vertical asymptote. All right, so where were we? Oh, domain. So what's the domain going to be? 3 to infinity. Okay? All right, and range is still all real. What happens if I put a +2 outside? This shifts up 2. Is the asymptote going to move? I mean, you can move the asymptote up 2, but guess what? It goes forever. So if I had added a 2 to this, the only thing I would probably do is take this point and move it where? Up 2. That goes to there, and I could redraw. Okay? All right. What else could happen? All right, let's see. Let's make sure you're clear with finding. So I'm going to give you a basic one. I want you to find the vertical asymptote, find the domain, find the range, okay? Call this technically example 1. Find vertical asymptote, domain, and range. I'll put one up here. So if I just write log of x plus 3, what's the base? 10. Could you graph that on your calculator? Yeah, you don't have to. You shouldn't need to. do both of those. And I'll show you how I'll think about domain without even using a graph. I'll show you how I do domain on both of these and I don't need a graph for it. I can just do it in my head. All right, so on the first one, remember what we said, whatever makes the inside 0 is going to be your vertical asymptote. So on the first one, I know my boundary is at -3. Now here's what I'm going to do. Without even graphing it, I'm just going to think, what are the numbers that are okay to plug in? Are they going to be left of -3 or right of -3? Well, if I tried to plug in a -4, I would get a negative, and I can't do log of a negative. If I try to plug in a -5, I would get -2. I can't do log of a -2. So I know everything has to be right of -3. Even though if I don't have the picture, I know that there's my vertical asymptote. I know that my domain has to go -3 to infinity. Okay, without even drawing it. Basically, what's happening to a basic log? It's moving which way? Left 3. Now, when I get to this one, you're going to say, you told us you can't take the log of what? And we're not going to. So here, first of all, take the inside, set it equal to 0. What do you get for the vertical asymptote? X equals 0. And make sure when you do asymptotes, they're equations. So don't say, well, I did my quiz and I put 0 down. That's not a vertical asymptote. X equals 0 is the vertical asymptote. So notice how I always write an equation. Now I'm going to think. So I know 0 is the boundary. Okay. Let's see, what if I try to plug in a 1? If I try to plug in a 1, I get -1. I can't plug in numbers right of 0. What if I try to plug in negative numbers? What happens if I plug in a -1? I get -1, which is 1, which is okay. So you can see the graph does this. If you looked at it on your calculator, if you were able to just draw, you could just change the base and do log of -x. But I can see the domain has to be -infinity to 0 because I can only plug in negatives. Because why can I only plug in negatives? Because negative of a negative is a positive. But now understand the transformation. What does a negative on the inside do? It flips it about the y. Remember your transformations. Negative on the inside flips about the y. Now, what if I had this problem? Log base 3 of x, but I have a negative in front. What does a negative on the outside do? Yeah, flip about the x. So it would be here. And if you flip it about the x, it's going to just, remember, rotisserie chicken, right? Those are the ones that are rotisserie. So it's going to go like this. So it doesn't change your domain or range. So you didn't change the inside here. So your vertical asymptote is still x is 0 and your everything else is the same. What it did change is it flipped it like that, okay? So knowing your basic transformations, use them. How do you know where the vertical asymptote is on a logarithm? Anything that makes the inside 0. Now, one more. They could start to get crazy with us and change the inside a little bit. They could get like crazy graphs. They could go, say, log of x squared minus 4. Okay. They could do something crazy like this. All right, so let me think for a second. He said the vertical asymptote is always what makes the inside what? 0. And you can graph this on your calculator, right? Just type it in and see, look at the picture. But if I set the inside equal to 0, what answers do I get? 2 and -2. All right. So I know that this has to have a vertical asymptote at 2, and I know it has to have a vertical asymptote at -2. So I've got my vertical asymptotes. Now, if I'm asked for domain and range, let's think for a second. What numbers can I plug in that make sense? Because remember, you cannot do the log of a negative and you cannot do the log of 0. So I see really 3 vertical segments here. It's either something left of -2, something in between, or something right. Well, let's say I try x is in here. Let's say I try to plug in a 0. What happens if I plug in a 0? Can you do log of a negative? No. So there's no graph in here. What happens if I plug in a 3? I get log of 9 minus 4. Is that okay? Yeah. So you know that there's going to be graph here. What happens if I plug in, say, a -3? If I plug in a -3, I get log, now look, it's -3 squared minus 4. So what happens when you square a negative? Positive? I get a positive. Okay? So where do you think the graph is? What spots? Is it in the middle? Is it on the left? Yeah. Is it on the right? It actually does this. Okay? You can use your calculator to help you, but you can see how I can think through what the domain is. So I know the domain has to be -infinity to -2 union 2 to infinity because I'm thinking about what I can plug in. Now, what can you use to help you? It costs $90. Calculator. Not an iPhone, right? Because that's like $1 million now. How about I can do an iPhone? $7,000. Or we can just charge $35 to your account every month for infinity. Basically what happens, right? Somewhere along those lines. Okay, good. Any questions? All right, so let's go through this. Use your technology to help you. Now, there is a button on the 84 that you can change the base if you want. So like right now, you only have a LOG button and an LN button. However, I'm rusty on it. Some of you know where to go. Where do you go to make, so let's say I want to go into Y1 and I wanted to type, let's say I want to do log base 3. I think you go somewhere and it allows you to pick a base A. Is it under math? Go under math, and then what do you hit? Is it you just scroll down? What number is it, Spencer? I don't know, what selection after you hit math? A? You gotta go way down? Oh, gosh.
It's the 11th.
Oh, okay, so scroll all the way down. Oh, is that the one you picked? Yeah. So you go, so if this is not on the 83, this is only on the 84. If you go math, and you scroll all the way down, what is it, selection A? It should say log base. And then when it comes up, it should allow you to type in a base there. And then you can graph whatever you want, okay? So use the graph to help you, okay? All right, I'll stop there. It's about the limit. So